Quantities in chemical reactions. Quantitative analysis measures the quantity of a substance present. It could be in terms of mass or concentration. And the limiting reagent is the reactant that is completely consumed in a chemical reaction. So it's all used up, there's none left over. That means it limits how much product you can make, because once you've used up that reactant, the reaction stops. You can't make any more product because you're out of one of your ingredients. Excess reagent. This is the reactant that there is more of than the reaction requires. So there's more present. Usually it's at least 10% extra of your excess reagent than your limiting reagent needs to use up. Let's do an analogy. You're going to bake some cupcakes for a school bake sale. Recipe on the box calls for 1 box of cake mix, 300 milliliters of water or milk, 75 milliliters of oil, and 3 eggs. These will make, 1 box will make 24 cupcakes. So you have the following: 10 boxes of cake mix, 2 cartons of eggs. How many eggs in a carton? So there's 12, right? So we've got a total of 24 eggs, 4 liters of milk, and 1 liter of vegetable oil. Which one is your limiting reagent? So if you use 10 boxes, if you want to make 10 boxes of cupcakes, how many eggs, milk, and oil will you need? Well, it says we need 300 milliliters of water per box. 10 boxes, so we need 3,000 milliliters or 3 liters of water or milk. We have 4 liters, so this is in excess. There's more than enough. 75 milliliters of oil per box. So 75 mils times 10 boxes is 750 mils, which is less than a liter of vegetable oil, so it's in excess. And we need 3 eggs, so we would need 30 eggs, but we only have 24. So that is our limiting reagent. The eggs is our limiting reagent. So if I only have 24, and each box needs 3, 24 divided by 3 is 8. I can make only 8 boxes of cupcakes. So it says, what is the maximum amount of cupcakes you can make? What's the maximum yield? It's not 240, because I can't make all 10 boxes. I can only make 8. So 8 times 24 is 192. So I can make 192 cupcakes with the ingredients that I have on hand. Eggs limits how much we can make, and the maximum amount we can make is how much we make at the point that our limiting reagent runs out. So 192 cupcakes. Limiting reagents limit the amount of product you can yield, but they can also be used to control a reaction. For example, winemaking. The sugar limits the amount of alcohol in your wine. And baking, the amount of baking soda or baking powder can change the texture of your baked goods. Quantities of limiting reagents must be carefully calculated and measured. How do you figure out how much excess reagent you need? Sometimes we do trial and error, and sometimes we don't even know how much of the limiting reagent we have. So you might have a reaction that forms a precipitate. You keep adding the second reactant until you stop making the precipitate. That's very time consuming. Sometimes we have these things called standard curves, which is a graph that's made from known amounts of a solute in a solution. you can run your sample against the standard curve to see where it fits. And they do this for blood and urine analysis. It's always a good idea to have at least 10% extra for your excess reagent. So if I require 20 moles of something, 10% of that would be 2. So I would actually use 22 moles, because I would take the original amount and add 10%. Or you can multiply it by 1.1, 100% plus 10%. So there are a couple of different ways to figure out which reactant is the limiting reactant. Sometimes we're given the quantities of reactants, we need to figure out the mass of product. Or we have the mass of product, we need to figure out how much reagent we need. To do this, we must determine which reactant is the limiting reactant, as this limits the amount of product produced. So the first step is always have a balanced chemical equation. Then you're going to calculate the moles of each reactant available. Convert both of the moles to the desired product using the mole ratio, product to your reactant, and calculate the mass formed from each. The reactant that produced the lowest and possible amount of product is the limiting reagent. So the limiting reagent limits how much product we can make. But we call it the maximum possible yield or the theoretical yield. So the smallest mass is the most you can make, so it's the maximum possible yield or the theoretical yield. So basically, these are the steps you're going to follow. You're going to calculate the moles of your reactant by using mass divided by molar mass. You're going to take that answer and multiply it by the mole ratio to figure out your moles of product. And then the mass of product is moles times molar mass. Do that again for reactant B. Whichever one of these two numbers is the smallest, that amount is your theoretical yield or your maximum yield, and the reactant that it came from is your limiting reagent. Okay, so let's do an example. Aluminum reacts with copper 2 chloride. If 0.25 grams of aluminum reacts with 0.51 copper 2 chloride, determine the limiting reagent. All right. So do we have a balanced chemical equation, first of all? So no, our chlorines are different. So we've got 2 on the left, and we've got 3 on the right. 2 and 3 both go into the number 6. So if I multiply copper 2 chloride by 3, I get 6 chlorines. And if I multiply aluminum chloride by 2, I get 6 chlorines, and then balance my elements. Now we've got a balanced chemical equation. We are going to need molar masses for our reagents. So we need for aluminum, we need for copper 2 chloride. And when you look on the right hand side, you've got 2 products. One is a solution of aluminum chloride, and the other is a solid. Chances are we're always going to be looking, well, almost always going to be looking for the solid, how much solid we make. So that's the one we're interested in. All right. So aluminum has a molar mass of 26.98 grams per mole. Copper 2 chloride is 134.45 grams per mole. Now please remember, the only place that you use coefficients is in a mole ratio to convert between moles. You do not use it to calculate your molar mass. You do not take the molar mass of aluminum and multiply by 2. Just the elements and how many elements are in the compound, not including the coefficient out front. And then copper is 63.55 grams per mole. All right. So we're going to figure out how much copper we can produce from aluminum and how much copper we can produce from copper 2 chloride. Now there is another way to do this using formulas, and that is to figure out, you assume one of your reagents is limiting. So maybe I assume aluminum gets all used up. I figure out how many moles of copper 2 chloride I have and how many moles of copper 2 chloride I need. I compare those amounts. If I need less than I have, then I am correct. Aluminum is limiting. But if I need more than I have, then copper 2 chloride is limiting. That's the traditional way to do it. All right, so aluminum. Moles of aluminum is the mass divided by molar mass. So 0.25 divided by 26.98. Now make sure that you carry more significant digits until your final answer. So we have 0.009. Those zeros don't count, they're placeholders. 2661 moles of aluminum. Now I have moles of aluminum. I want to convert them to moles of copper. So what you want goes on top. What you want to get rid of goes on the bottom. So aluminum's going to go on the bottom because it will cancel this aluminum. So this aluminum down below cancels this aluminum up top. And there's 3 copper for every 2 aluminum. So if I calculate this, we end up with 0.013899 moles of copper. Now we have moles of copper. We need to figure out the mass of copper. So mass of copper is moles times molar mass. So now I'm going to take my moles of copper, and you always have to make sure you've got the right number of moles. If it's copper, you have to use the moles of copper and the molar mass of copper. So multiply this by 63.55 grams per mole, and we get 0.88329 grams of copper. If we rounded that off to proper sig figs, it would be 0.88 grams. Okay, now we're going to repeat this for copper 2 chloride. All right. So now we have, I'm going to put CuCl2. Moles is equal to 0.51 grams divided by 134.45 grams per mole. So this is 0.0037932 moles CuCl2. So now we need to convert it to copper. We want copper, so it goes on top. We want to get rid of CuCl2, so it goes on the bottom. CuCl2 cancels. 3 divided by 3 is 1, so we have 0.0037932 moles of copper. Now, take that number of moles Some of you would have realized we could have stopped at the number of moles for this question, but this way we're also calculating theoretical yield, which most questions will ask for. So there we go, we've got the number written down, times 63.55, and we get 0.24106. Totally wrote those two numbers backwards. Grams, because moles cancel. And so 0.24 grams of copper. All right, so then you compare these two numbers in the square boxes. Which one is the smallest amount? So that is going to be the theoretical yield. So 0.24 grams of copper. That's the most copper we can precipitate out, with 0.25 grams of aluminum and 0.51 grams of copper 2 chloride. So that makes the reactant that this second number here came from, this 0.24, this came from CuCl2. So CuCl2 is the limiting reagent. It limits how much product we can make. So that's how you basically approach these questions. Figure out the number of moles, convert moles to product or whatever else you're supposed to convert to, and compare the numbers.